Welcome everybody, I am a teacher from Ilm Online Academy. In today's video, the topic is acids and bases. This is basically chapter number 11 of the ongoing series for the chemistry 0620, and in today's video we'll be having a look at the acids and the bases. So the contents which are included in chapter number 11 and which we will discuss today are the nature of the acids and bases, and the second one is the characteristic properties of acids and their reactions. So further ado, let's just begin and first start with the introduction of the acids and the bases. Acids are the substances that dissolve in water and they produce H positive ions. So they release hydrogen ions when they are mixed in the water, and other properties of the acids include they have a pH which is less than 7. First, I am telling you about the general features or the characteristics of the acids. So they have pH which is less than 7. 7 is the neutral pH, less than 7 pH is of acids, and greater than 7 up to the 14 is the pH of the bases. So they lower the pH when the acid is stronger. Stronger the acid, you can say that, then the pH is lower the pH. Means if the pH is 1 or the pH is 2, that means the acid is much stronger. And third, we have if the acid is stronger, then the concentration of hydrogen ions is higher. Stronger the acid means that more concentration of H positive ions. Next, the characteristic of acid is acids are also known as proton donors. Means they donate the protons when they are dissolved in the water. So, and strong acid is an acid that completely dissociate in the aqueous solution, and weak acid is partially dissociate into the aqueous solution. Now we have the example of the acids. The most common example of the acid is hydrochloric acid, which is HCl. So this is the strong acid, not much stronger as compared to the sulfuric acid, but it is also the stronger acid. So hydrochloric acid, when we have the solution of the hydrochloric acid, then this acid dissociates completely into, like we have HCl, when it dissolve or mix with the water, it does dissociate completely into the ions H positive and chloride ions, hydrogen ions and chloride ions. So acids always give the protons when they are dissolved in the water. So that's why we call it as the proton donors. So next, this is the strong acid, and another example of weak acid is the ethanoic acid. So when ethanoic acid, which is the weak acid, this is the formula, and when it dissociates, what will happen? It forms H positive ion. Acids always give proton, so they are known as proton donors. Plus we have CH3COO negative ions. So this is the weak acid, which is an example of the weak acid and a strong acid. In case of strong acid, we have hydrochloric acid, and in case of weak, we have ethanoic acid. So these are the properties and examples of the acids. One more thing that is observable here, you can see the arrows which I am writing in the equations of strong acid and the weak acid. Hydrochloric acid is a strong acid, and strong acid completely dissociates in the aqueous solution by giving the hydrogen ions and the anions. So this is represented by the irreversible equation, and you can see here just the forward arrow. And the weak acid, which is the ethanoic acid, this one is the reversible reaction that indicates the partial dissociation. So that is the main difference between the strong acid and the weak acid. Weak acids give or indicate the partial dissociation by the reversible reaction. They are partially dissociate into the aqueous solution, and strong acid is an acid that completely dissociate because of its high concentration or low pH. Low pH means the stronger the acid is, so the strength of the acid or the stronger the acid means that it completely dissociate into the ions of hydrogen ions and chloride ions or any other type of anions. So this is about the acids. So now there are two types of acids, organic acids and mineral acids. So now we'll talk about the organic and the mineral acids. Organic acids are mineral acids are also known as the inorganic acids, and organic acids are the organic acids that contain the carbon atoms in their molecular structure, and they are derived from the living organisms. As the word organic says that they are derived from the living organisms, and they have carbon in their structure. That is the main point about the organic acids. And the examples that are of organic acids are the acetic acid, or you can say that the ethanoic acid that is found in the vinegar. For example, CH3COOH, this is the acetic acid that is found in the vinegar, that is used in food preservation as a chemical reagent. We have citric acid. Citric acid has the formula C6H8O7. And next examples of the organic acids are the methanoic acid, which has the formula HCOOH, lactic acid, and other one is the ethanoic acid. All these are the weak acids, and these are included in the organic acids. The main thing about the organic acids is that they have carbon in their structure like this, and they are derived from the living organisms. So this is about the organic acids. Next we have mineral acids. Mineral acids are also known as inorganic acids, as I already told you earlier, and they do not contain carbon atoms in their molecular structures, and they are derived from the minerals. And they are often stronger than the organic acids. These are mostly weak acids which has pH like 4, 5 or 6. They are derived from the minerals, and they are much stronger as compared to the organic acids and not contain carbon in their molecular structure. These are the differences between the mineral acids and the organic acid, and the example of the mineral acids are hydrochloric acid, HCl, which is the stronger acid that is used in industry processing, cleaning, and also for the laboratory reagent. We have sulfuric acid, which is the formula H2SO4. This is much stronger acid, and it is used in car batteries, used in making fertilizers, paints, and also in detergents. Next we have nitric acid, which is also included in the mineral acid, and this is also the stronger acid, and the uses are in making fertilizers and also explosive. Next we have phosphoric acid. So you can see here all these acids do not contain the carbon atom in their molecular structure. Phosphoric acid is used in the food additive, fertilizers, and also in the cleaning agents. So the key differences between these two is that organic acids contain the carbon and mineral acids do not. Organic acids are derived from the living organisms, whereas mineral acids are derived from the minerals. Mineral acids are generally stronger and more corrosive than the organic acids, which are weaker acids. And organic acids are often used in food and pharmaceuticals because of its nature, that is of weak. They are of weak in nature, and they have low pH. sorry, they have you can say that they have the pH lower than 7, but not like 1, 2 or 3. Organic acids have the pH like 4, 5 or 6 or less than 7. But mineral acids are used mostly in the industries and in so many chemical processes. So these are the differences between the type of the acids, and that help in selecting the appropriate acid for the various applications. So these are the common acids that we are using. Next we'll move towards, or we'll talk about the bases. So these are the substances that release hydroxide ions. Acids are the substances that release hydrogen ions, and these are the substances that release hydroxide ions when mixed with the water. They have pH greater than 7, pH more than 7, and the strongest base has the pH of 14, and the weakest base has the pH greater than 7, like 7.1, 7.2, 7.3 or up to the 8. This is the pH of the weaker base. The higher the pH, the stronger the base. If pH is much higher, then this arrow indicates the higher. If the pH is much higher, like 13, 14, then the base will be much stronger base. And if the base is stronger, then that means the concentration of hydroxide ions is much more. Bases are usually the oxides or hydroxides of the metals. As I already told you about the oxides, oxides are the substances when oxygen combines with them, and hydroxide means when OH, hydrogen, and oxygen combines with any. So oxides are oxides, and hydroxides of metals are the bases. Like I give you the example here, we have NaOH. Sodium hydroxide is the base, and this one is the hydroxide that is present with the metal. So hydroxide of metal is a base, and oxides of metal is also a base. Like we have in the base we have oxygen that is present there, and that shows that this one is the base with the substance or the metal. Bases are the substances that can accept the hydrogen ions, and they are known as proton acceptors. So we call it as the proton acceptors. Acids are the proton donors, and these are the proton acceptors. They accept the hydrogen ions. So bases are also known as the proton acceptors, and bases which are soluble in water, we call it as the alkalis. They often have a bitter taste, and also they have a slippery feel. Some examples included. So now we have alkalis, bases which are soluble in water. You call it as alkali. So the examples of the bases are sodium hydroxide, which I already talked about, NaOH, and sodium is the metal, and we have hydroxide, which is the hydroxide. This is also known as the caustic soda, and it is used in soap making, drain cleaners, and also in various industries. We have potassium hydroxide, KOH. This is also the hydroxide of the metal that is used in the production of fertilizers, soaps, and also in as a electrolyte in the alkaline batteries. We have calcium hydroxide, calcium hydroxide is known as the slate lime, and it is used in the construction industry for making mortar and also in the water treatment. This is also used there. We have magnesium hydroxide, the example of the base. We have sodium bicarbonate. So all these are used as a base in various industries and also in the everyday products that are used due to their chemical properties. So next we have amphoteric substances. amphoteric. These are the substances that behave both as the proton acceptors and also proton donors. Means they act as a base sometimes, and sometimes they act as a acid. So both proton acceptors and donors, and they are known as the amphoteric substances. Like, for example, we have aluminium oxide Al2O3 that sometimes accept the protons and sometimes that donates the protons, aluminium oxide. And we have zinc oxide. So amphoteric oxides react with the acid or the bases to produce the salt and the water. So these are the both of these are the amphoteric oxides that can behave as both as a proton acceptors and also as a proton donors. So that's why we call it as amphoteric substances. And the example include the aluminium oxide and the zinc oxide. These are the amphoteric oxides because oxygen is present there. So when oxygen is present there, you call it as the oxide. That substance is known as oxide when oxygen is attached to them. So these amphoteric oxides react with the acid and the base to produce the salt and the water. So these are the amphoteric oxides. Next we will talk about the indicators. So indicators are the substances that change in color when they are added to the acidic solution or when they are added to the alkaline solution. And the examples of the indicators are, we have litmus. You may be heard about the litmus paper. And next we have phenolphthalein. So the easiest way to detect whether a solution is acidic or basic, we can use the indicators. And these are the substances, when we put them into the acid or the alkaline solution, they change in color. And the examples of the mostly used indicators are the litmus, phenolphthalein, and also we have one more, which is thymolphthalein. Litmus is extracted from the lichens and is purple is in neutral solution, and it is purple in neutral solution. When added to the acidic solution, it turns red. So the litmus turns red when it is added to the acidic solution, red, and in neutral it is in purple. So this color change of litmus is the result of the chemical reaction. Substances with the opposite chemical effect to the acids are needed to reverse the color change, and these are known as the bases. So when litmus is added to the base solution, it turns to blue. Blue means the base, and if the color is red of the litmus paper, then that means it's the acid. We can also use the litmus paper, that is the paper that has been soaked in the litmus solution. Litmus paper is mostly available in blue and in red forms, and the one which I am talking here about, the litmus which is purple in the neutral solution, that is the common indicator. And the blue form of the litmus paper changes the color to the red when it is dipped into the acidic solution, and when red litmus paper turns the blue in the alkaline solution, right? So we have a simple memory aid, visual memory aid, that help you to remember the color change that litmus shows. Like, we have acids, this is the memory aid for you. This is the acid, and next we have the base. So for the acids, acid ends at the D, so that means RED, red. So the color change of the litmus in the acid is red. And if we talk about the blue, the base starts with the letter B, so that represents the blue. So this one is the memory aid for the color change of litmus in the red with the acid and blue with the base. So the presence of water is also very important for this one, and we will talk about this further. So this is the litmus color change in case of acidic solution and in case of basic solution. We also have some more indicators like phenolphthalein and thiamolphathene and methyl orange. So this is more important one, so you have to remember this one, which will help you in solving so many questions. So next we have the neutral color also. I think you should know the neutral color of the litmus is purple. Purple is the neutral color, blue is the basic, and red is the acidic. Next we have thiamolphathene. So the neutral color of thiamolphathene is colorless. It is colorless in neutral solution, which is not the acidic or the basic solution. In case of acid, it is also colorless. But when it is added to the base or the alkali, it turns blue. So blue, we have different indicators and they have different color change. So when thiamolphathene, which is the acid base indicator, that is colorless in the acidic solutions and blue in the alkaline solutions. So next we have methyl orange. Methyl orange is also an indicator for as a acid base indicator, and methyl orange, that is red in the acidic and yellow in the alkaline. Red in acid and it becomes yellow in alkali solutions, and the colorless is orange. Neutral is orange. In neutral solutions which has a pH 7, they have the color orange, red in the acidic solutions, and it gives yellow color in the alkali solutions. So there is also the impact or the presence of water, that is more important in the action of the acid and bases. Like when we use the litmus paper, when litmus paper is used, litmus paper only absorbs the solution or the liquid when it is added. If there is a gaseous state, we want to check the pH of that, it is not possible. So to test the gases with the litmus paper, it must always be damp, so the gas needs to dissolve in the moisture to bring about the color change. So gas needs some moisture if you want to check the pH by the litmus paper, because litmus paper, when it is soaked in the solution, then it shows the color change or the pH. So for the test of the different gases, we can use, or we have to use the that needs moisture, and if we are using the litmus paper, so that should be damp. And some other indicators that we have also heard about that have different color changes from the litmus, and the color changes are sometimes easier to detect than for the litmus, like thiamolphathene, methyl orange, and phenolphthalein. All are used. Next we have universal indicators. Now we have the universal indicators. You can say that these are the indicators or the mixture of indicators that have different colors in the solution of different pH. For example, universal indicator is a mixture of indicator dyes, and such indicator is useful because it gives a range of color or a spectrum. As you can see here, this is the spectrum or the range of colors that we have after adding the universal indicator, and it depends upon the relative strength of the acid or the alkali that is added. If it is much stronger or it's weak, it depends upon that. So when we use the universal indicator paper, we have the solution of different acids that produce different colors depending upon the acidity, and the solution of the same acid with different concentrations will also give the different colors, as you can see here. If we have the much stronger acid like which is a pH like 1 or pH 2, then it gives a color that is red, and if it's a weak acid, then it gives yellow or orange, and if it's a neutral solution, which is the center one, it gives the green color, and blue is the weak alkali, and indigo or violet or dark purple indicates the strong alkali. So the more acidic solutions like the battery acid that turns the universal indicator into the bright red, and the less acidic solution will turn the indicator into the orange red. So these are the color differences that are produced with the different alkali solutions and the acidic solutions, and the most alkaline solution have a color of violet, as you can see here. This is the violet color, and the upper one is the pH paper. So in this picture we have how the color of the universal indicator changes in the solution of the different pH values. So we have a pH paper, as you can see here above the universal indicator tubes. So the pH paper has a pH which is starts from the 0 to the 14. This one, which is 7, this is the neutral pH that represents the N. If we move towards the left, then the pH is lower. pH is lower, and that means it's the 0 or 1 or 2 is the pH of the strong acids. And if we move towards 4, 5, 6 or 3, this is the pH of the weak acids. Like we have acetic acid, that is a weak acid, and then we have organic acids. All our organic acids are mostly the weak acids. We have citric acid, lactic acid, formic acid, all these are the organic acid. And mineral acids, which are stronger acids that have pH from 0 to 1. 0, 1, 2, 3, all are the mineral acids, like nitric acid, hydrochloric acid, all are those. So if we move towards the right side, then we have the pH of the base, and the strongest base has the pH which is greater than 7. This one is the strongest pH for the alkaline or the basic solutions, and the weakly are those which are present 8, 9 or 10 pH. Acids have a pH less than 7. The more acidic is the solution, the lower the pH is. And neutral substances, for example, pure water has a solution which has a pH of 7, and this one is the neutral pH, which is the pH of 7. Alkalis always have a pH that is greater than 7. So this is the pH scale that running from below 0 to 14, and it is used to express the acidity or the alkalinity of a solution, and the neutral solution has a pH of 7. So it's important to remember that as we move down from the pH 7, the solution is getting more acidic. Like 0, 1, 2 is getting more acidic, or you can say that more stronger acid has the pH from 0, 1 and 2. And moving up from pH 7, the solution is getting more alkaline. If we move towards the right, then that means the solution is getting more alkaline. So the pH values of some I will also tell you now the pH values of some common acids, like for example, we have the highly acidic substances and highly basic substances. Hydrochloric acid has the pH 0 because it's the strong acid, and lemon juice has the pH. Lemon juice has citric acid, so it has a pH 2.5. We have vinegar, which contains acetic acid. It has a pH of 3, and acid rain has a pH of 4.4, which contains nitric acid or sulfuric acid. it has the pH 4.4. And urine is also slightly acidic, which has a pH 6. Oh, I'm sorry, the rainwater has a pH 5.6. I skipped the rainwater here. So the rainwater has the pH 5.6 and acidic rain has the pH 4.4, which contains the acid. Rainwater is slightly acid because of the presence of the carbon dioxide gas from the air. Milk has the pH 6.5 and the pure water has a pH of 7. If the water is pure, then it has the pH which is 7. And then we'll move towards, here you can see this one. This is the highly acidic substances. HCl is the highly acidic, and we have slightly acidic substances like urine and milk, slightly acidic or poorly acidic, you can say. And the pure water, this one is the neutral. And next we'll move towards the bases. Now we have the blood, which is poorly alkaline and it has a pH of 7.4. Then we have baking soda, which has a pH of 8.5. And then we have ammonia, NH3, which has a pH of 12. Then we have NaOH, sodium hydroxide, which is the strongest base, and this has the pH of 14.0, and the color of the solution will be violet or indigo or dark purple. So this one is the sodium hydroxide is highly alkaline. And blood is poorly alkaline. So you can see here there's a difference as we getting or move towards or moving up from the pH 7, the solution getting more alkaline from poorly to the highly alkaline solution. As we move down from pH 7, the solution is getting more acidic. So this is about the universal indicators and also the indicators. Next we will talk about the importance of the hydrogen and the hydroxide ions in the acid and the alkali solutions. As we know that if the solution of the acids are checked to see if they have to conduct electricity, we can find out that they are electrical conductors. They conduct electricity much better than the distilled water. Why? Because they have ions that are present there. Electricity is conducted only just because of the ions, free ions that are present in the solution, and the second because of the free electrons if it is present. So this is the two reasons why the electricity is conducted in any solution. So in case of acidic and alkali solution, we have ions that are present there. Hydrogen ions, which are the acids are the proton donors and alkalis are the proton acceptors. So hydrogen ions and hydroxide ions are present there. So this shows that the solution contains the solutions of acid and bases contain the ions. So just because of the presence of the ions, they conduct the electricity. Water itself also contains very few ions. In the pure water, the concentration of hydrogen ions and the hydroxide ions are equal. All the acids dissolve in water to produce hydrogen ions and bases give the hydroxide ions. So acidic solutions contain more. If we talk about the acidic solutions, they have more hydrogen ions as compared to the hydroxide ions. More H positive ions are there because they are proton donors, and they have less hydroxide ions. The opposite will be in the basic solution or the alkaline solution. And the pH scale is also designed around the fact that the acidic solution have this excess of the hydrogen ions. Alkali solutions also conduct the electricity better than the distilled water, because when alkalis dissolve in water they produce hydroxide ions. Therefore all the alkali solutions contain an excess of hydroxide ions. And we can also have the indicator which we read before, the litmus, that is affected by the presence of hydrogen ions or hydroxide ions. So if hydrogen ions are present in the acidic solution, so this solution will turn the litmus into the red. Litmus will be turned into the red because of the hydrogen ions. And if we talk about the basic solution have more hydroxide ions as compared to hydrogen ions. So just because of the hydroxide ions in the alkali solution, the litmus is blue. As I already told you about the memory aid for the remembrance of the color of the litmus of acidic and the basic. So now we have the diagram which shows you about the acidic and the basic solution. First we talk about the solution which has a pH equal to 7. In case of water, when it is dissolved, the water has equal number of hydrogen ions and hydroxide ions. When water is dissociated, you can see here H2O, when it is dissociated it forms hydrogen ions plus hydroxide ions. So one hydrogen ion and one hydroxide ion from one molecule of water. According to this, we have a balanced like this one which is present here, and this is balanced from the mid. So we have hydrogen ions and we have hydroxide ions. So there is a balance in pure water. Why there is a balance? Because hydrogen ions are equal to the hydroxide ions in the pure water. They have equal number of ions in the water molecule when it is dissociated. So if pH is 7 neutral. Why? Because pure water has equal number of hydrogen and the hydroxide ions. Next, if we talk about the pH which is lower than 7, pH less than 7, and the litmus turns it red. Why the litmus turns it red? Because like this will be like this one. Why? You can see here in this diagram we have more hydrogen ions. Hydrogen ions are more because acidic solutions, in case of acids, there are more hydrogen ions as compared to the hydroxide ions, because acids are the proton donors. In case of acidic solutions, acids also give hydrogen ions, and water in which it is present, water also gives the hydrogen ions. So there is more concentration of the hydrogen ions in case of pH which is less than 7, and they turn the litmus paper into the red. So the pH will be less than 7 and they have more concentration of the hydrogen ions. So just like for the bases which has pH greater than 7, so that shows there is an increase in the hydroxide ions. Bases, because bases are the hydroxides of the metals and the oxides of the metals, so they give more hydroxide ions as compared to the hydrogen ions. Hydroxide ions are released from the water and also from the base. So in alkali solution, hydroxide ions are more as compared to the hydrogen ions. So this is the pH and the balance of the hydrogen ions and the hydroxide ions in the solution of the acid and the base. Next, if we talk about the ions that are present there, like for example hydrochloric acid. Hydrochloric acid gives us hydrogen ions plus we have chloride ions. In case of nitric acid, HNO3, it gives us hydrogen ions plus nitrate ions. Next, if we talk about some bases or the alkalis like potassium hydroxide. Potassium hydroxide gives us potassium ions in the aqueous solution plus we have hydrogen ions. Hydroxide ions. And then if we have calcium hydroxide that is present as in the lime water, then that it has, or it gives us calcium 2 positive, plus we have hydroxide ions OH negative into the aqueous solution. So these are the ions that are present in the solution of some acids and the bases. So now we will talk about the difference between the alkalis and the bases. So alkalis, these are the substances, as we have read before, that dissolve in water to give the solution, and they have a pH which is greater than 7, and they turn the litmus paper to blue, and the solution of this one contains the excess of the hydroxide ions. Hydroxide ions are mostly in excess in this one, and they are soluble in water. So bases also contain, or they also give the hydroxide ions, but there is just a minor difference between the alkalis and the bases. So when acids are added to the alkalis, they give the neutralization reaction between the acid and the alkali, and they neutralize the excess acid or the excess hydrogen ions. So they are soluble in water. But when we investigated that further, it was found out that all the metals, oxides and hydroxides, would neutralize the acids whether they dissolve in water or not. So therefore the soluble alkalis are just a smaller part of a group of substances. Oxides and hydroxides of metals are also there to neutralize the acids. So these are known as the bases. Bases are, this is the broader term, we can say that, and this one also contains the oxides and the hydroxides of the metal. So most of the bases, mostly you can say that mostly bases are insoluble in water. All the alkalis are soluble in water, but and thus makes the few bases that do not dissolve in water more significant. They give a special name, that is the alkalis. They are generally used as a aqueous solution. So now I am here to draw the Venn diagram for or to show the base and the alkalis, the relationship between them, all the alkalis and the bases. So this one is the Venn diagram for this. Suppose this is the Venn diagram for the bases. We have all the bases that are present here. So base is a broader term, and that we have bases like oxides and the hydroxides, like copper oxide, magnesium oxide, calcium oxide, sodium hydroxide, copper hydroxide, all can neutralize the acid. But there is a smaller one that is present in the bases, which are known as alkalis. Alkalis are a group in the bases which are soluble bases. You can say that alkalis are the soluble bases. Like we have sodium hydroxide, we have potassium hydroxide that is soluble in water. So bases is a broader term. Those bases which are soluble in water, we call it as alkalis, and those bases which are insoluble in water, that are not included in the alkalis. Alkalis are generally soluble in water, and they give the aqueous solution. So that's why a base can neutralize the acid, and when the bases are neutralized with the acids, they give the salt and the water. So this is just a minor difference between the base and the alkalis. Bases is a broader term, alkalis is a smaller group in the bases, and the soluble bases are known as the alkalis. But if we talk about the bases, contain all the soluble and the insoluble ones. Now we have another example of our stomach. Our stomach contains hydrochloric acid that will help to digest our food, a dilute solution of hydrochloric acid, and if it present is in excess, then it causes the indigestion. So to treat this, we mostly use antacids. For this one, antacids are mostly used if excess of acid is produced in our stomach, that may be due to the food or the diet you are taking. And the antacids are the group of bases like magnesium hydroxide, and we have mostly carbonates with no toxic effects on the body, so they can be used to neutralize the effect of the acid in digestion. And acid means these are the compounds that are used against the acids. So the compounds that are used medically to treat the indigestion by neutralizing the excess stomach and that is produced in our acids. So we have this one. So alkalis are mostly strong, that are soluble in water, like sodium hydroxide, potassium hydroxide, calcium hydroxide, and they have different uses. Like potassium hydroxide is used in soap making industries and also in the biodiesel. Calcium hydroxide is used to neutralize the soil acidity and also acidic gases that are produced by the power stations. And if we talk about the bases like calcium hydroxide, calcium oxide and magnesium oxide. Magnesium oxide is used in antacid indigestion tablets, and also calcium oxide is used for neutralizing the soil acidity and for industrial waste. So we have this one, the properties of the acids and bases, which we have read here. Bases are the oxides of metals and hydroxides. They neutralize acids to give the salt and water, and they are mainly insoluble in water. So these are the properties of the acids, bases and the alkalis. You can see here. Next we talk about the acidic oxides. Previously we have heard about the amphoteric substances and also the amphoteric oxides in which the oxygen is present. So acidic oxides are formed when a metal combines with the oxygen. When a metal is combined with the oxygen, so metal plus oxygen, it forms the acidic, when a metal plus oxygen reacts, it forms the basic oxide. And the example of this one are copper oxide plus we have calcium oxide. So these are the example of the basic oxide. Next, if we talk about the acidic oxide, these are formed when non-metals combine with the oxygen. In case of base, we have a metal, and in case of acidic oxides, we have non-metal that reacts with oxygen or that combines with the oxygen to form the acidic oxide, and when they dissolve in water, they produce acidic solution. For example, we have carbon dioxide, we have sulfur dioxide, and plus we have nitrogen oxide. Nitrogen is a non-metal, sulfur and also carbon, all are non-metals. So when non-metals combine with them, they form the acidic oxides. We have also the neutral and the amphoteric oxides, which we have read before. In case of amphoteric oxide, we have the examples of the aluminum oxide and the zinc oxide. Metal oxides that can react either as an acid or as a base to produce a salt in water, these are known as the amphoteric compounds. And acidic oxides are those that react with the base and dissolve in the water to produce the acidic solution. And basic oxides are the oxides of a metal that will react with the acids to neutralize the base. So this is about the acidic oxide, basic oxide and the amphoteric oxide also. We have also read about the amphoteric oxides. So now we'll move towards the next one, which is the characteristic reactions of the acids. So this is the last topic of today's chapter. So we have the characteristic reactions of the acids. There are three major chemical reactions in which all the acids will take part, and these reactions are best seen during the by using the dilute acidic solution. In these reactions, the acid reacts with the first we have the acid, the reaction of the acid with a reactive metal, acid plus metal. The second major chemical reaction of the acid are the acid with the base or alkali. This is also known as the neutralization reaction. When acid and base react together, they neutralize the solution and form the salt and the water. Next, we have the reaction of the acid with the metal carbonate. any metal is present with the carbonate or hydrogen carbonate, you call it as, then these are the major reactions for the acid. So one type of product that is common to all these reactions, they produce a metal compound that is known as the salt. This is the common product of all these reactions, that is the salt. So salt, like for example, we have sodium chloride that we put in our food, and this is the main salt that is found in the seawater. A salt is a compound that is formed from the acid when a metal takes the place of hydrogen in the acid. So the acid from which the salt is made, it is also known as the parent acid. So now we'll talk about the first category for the reaction of the metals, which is the chemical reaction between the acid and a metal. So this is the first one. First, I will discuss with you the general equation when acid react with the metal. So when acid plus metal react together, they produce salt plus hydrogen. So this one is the general equation for the chemical reaction of the acid and the metal. Metals are quite reactive and they can be used to displace the hydrogen from an acid safely. Hydrogen gas is given off, and the salt that is made, that depends upon the combination of the metal and the acid that we are using. So the salt made depends upon the acid reacted with the metal. We have hydrochloric acid. Like if hydrochloric acid is there, the hydrochloric acid always give the chloride for the salt, and the metal will take the anions from the acid, and then it forms a salt. If we talk about the nitric acid, HNO3, that gives nitrate, and nitrate will form the salt. And if we talk about the sulfuric acid, H2SO4, sulfuric acid will give the sulfate ions, and that forms the salt. So now we have the example. This reaction is too violent because of the reactive metal that we are using here. So according to the general equation, we have magnesium metal, which is quite reactive, that reacts with the nitric acid HNO3. So what will happen here? Hydrogen ions will be liberated and we have nitrate ions. So magnesium reacts with the nitrate ions because magnesium has the positive charge. So when it forms here, we have after reaction the salt, which is magnesium nitrate, MgNO3 2, plus we have hydrogen gas. So we are using here the 2 moles of the nitric acid. So this is the equation for the reaction between the between the acid and the metal. When metals are too reactive and the reaction is violent, so when metals react with the acid, it forms the salt. Like in this example, we have magnesium nitrate plus hydrogen gas is always liberated in these type of reactions. Another example is we have zinc metal, and when zinc reacts with hydrochloric acid, zinc will take the chloride ions and it forms zinc chloride salt plus hydrogen gases always liberated, like this one. Zinc has a positive 2 charge and it will take 2 chloride ions with it to make a neutralized compound, that is the salt ionic compound zinc chloride plus hydrogen gases liberated. So this is the reaction of an acid and a metal. So now we'll move towards the second major chemical reaction of the acid with the bases and also with the alkalis. This is the neutralization reaction. So the reaction of the acid plus we have a base or a alkali. So when acid reacts with the base, it forms the salt and water, and this one is the general equation. The salt plus water is released here. The salt produced by this reaction will depend upon already or always the combination of the reactants that we are using. To make the particular salt, you can choose a suitable solid and a base, acid and a base, to give the reaction of a salt and the you want. So we have the example of this one, like hydrochloric acid, which is the acid that reacts with the base, like NaOH, sodium hydroxide, that forms the salt. what will happen here? Hydrogen ions are separated and we have chloride ions. So salt always contain a metal and a non-metal. So this metal that is present is sodium. So sodium will react with the anions of the acid that we are using. So we have sodium chloride salt plus water is being produced here. In this reaction, we can see that hydrogen ions of the acid are matched by the hydroxide ions from the alkali to produce the water. Like hydrogen ions, H positive ions plus hydroxide ions of the alkali or the base react and they form the water, that is H2O. If we mixed in correct amounts, then the alkali exactly neutralizes the acid. So we have also the neutralization reaction that occur by the insoluble base with the base acid. Like we have magnesium oxide, that is the insoluble base that reacts with the nitric acid HNO3. You will take the 2 moles of the nitric acid here because magnesium has the charge of positive 2. So magnesium will take here magnesium nitrate ions plus water is being released here. So we have here the example of the combination of the salt and the water that is produced when acid react with the bases or the alkalis. We have some another examples like sodium hydroxide. Sodium hydroxide is a base. You can see here this one, this sodium hydroxide, this is the base, and now we'll see the salt from which it is made. Sodium hydroxide, if it reacts with the acid like hydrochloric acid, if sodium hydroxide reacts with the hydrochloric acid, then what will happen? We have sodium chloride that is produced, and NaCl. If we want to produce a sodium chloride, then you have to use the base sodium hydroxide, and the acid that is being used is hydrochloric acid plus water is also released from this one. So you can check which the salt made from which base or the acid, so you have to use a particular type of the salt and the base. Next we'll talk about the third type, the reaction of the acid with the carbonates. The third one is the reaction of the acid plus we have metal carbonate. And then we have water plus we have salt plus the third product, that is carbon dioxide, is also liberated here in case of the reaction with the acid and the metal carbonate. Effervescent is produced in this, so you can easily check how carbon dioxide is released or not. So we have the example of this one when we have hydrochloric acid HCl that reacts with the metal carbonate. Any metal you can take, like if we take the calcium, so calcium carbonate that reacts together. So what will happen here? We have the salt plus water plus carbon dioxide. You can write first water H2O plus carbon dioxide that is always released when carbonates react with the acid, plus the salt that is released here. Salt is made from the metal that comes from the base. So the metal that is present in the base is calcium, and it comes from the non-metallic part from the acid, that is chloride. So calcium chloride is the salt that is produced here, CaCl2, like this one. So salt always comes, salt has two parts, the metal, and metal comes from the base, right? And we have the non-metallic part, and that non-metallic part comes from the acid. That always comes from acid. So this is how the combination of the metallic part of the base and the non-metallic part of the base forms the salt. So this is the reaction of a example of the reaction of the acid and the carbonate that produces the water, carbon dioxide, and also the salt. Next we'll talk about something about the strong acids and the weak acids. We have already read about that, like the complete dissociation and also the partial dissociation. So now I am concluding all this. We have the complete dissociation and the partial dissociation. If the acid is weak, like for example ethanoic acid, if the acid is weak like ethanoic acid CH3COOH, then it forms a reversible reaction, only a small fraction of the covalently bonded molecules is dissociated into the hydrogen ions, plus we have CH3COO negative ions or ethanoate ions. So complete dissociation into the ions or complete ionization results in the strong acid. If we talk about, this is for the partial dissociation and happens in the weak acid. If we talk about the strong acid, H2SO4, the reaction is always forward, and we have hydrogen ions plus we have sulfate ions that are released here like this. So this is the complete dissociation happens only in a strong acids. So this is how the strong acids and the weak acids comparison, and we can compare two acids and trying to decide whether they are weak or strong. It is important to compare the two solution of the same concentration. If the concentration are same, then you can use the pH, the conductivity, or the rate of the particular reaction to help for judgment of the extent of the ionization. Strong acid is completely ionized when dissolved in the water. This produces the highest possible concentration of hydrogen ions in the solution, for example hydrochloric acid. And weak acid is an acid that is partially dissociated into the ions in water, and it usually produces a low concentration of the hydrogen ions in the solution, like for example ethanoic acid. So this is all about today. Hope you understand all this. If you have any question or any query, you can ask in the comment box. If you like the content, then please like and subscribe the channel. We'll meet in the next video.